So we continue to look at the fundamentals of precalculus, and the last section that we'll look at is the coordinate geometry. Now, with coordinate geometry is that you put everything on the coordinate plane or Cartesian plane. So it's got the y-axis and x-axis. This is when you are dealing with 2 dimensions. This can go on to include other dimensions. Okay, so this is 2 dimensions. And so what is crucial is that we need to be able to understand that once we have this plane here, we can actually put points on there and be able to get various distances. Could be maps, could be some other readers that you are, real-time readers. You're calculating maybe distance between 2 events. So that could be application. So you can calculate the distance. Once you do the distance, that distance you can actually look at its midpoints. Midpoint is very crucial because that you can apply when you're doing the equation of the circle. That relies on distance as well. The other concept that we can get from this is the gradient of the line that you can use to formulate the equation of the straight line. So basically, the gradient is change in y against the change in x. So it will tell you how much there is a variation in y compared to the variation in x. So for example, here, this tells you how much y is changing with regards to how much x is changing. So for example, if I've got a line like this, I'll be saying that y is not, x is not changing whilst y is changing. When I have something like this, x is changing whilst y is not changing. Sorry, not 0, y is constant, okay? So we're saying that y is constant at that point, okay? Then, so we can use this to calculate the equation of that straight line, okay? Another concept that we can do is, now we've done a lot of quadratic equations, so you can actually sketch the equation onto, or the quadratic expression onto something like that. It could be like that, or it could be this way. Depends. So these have got various applications in mathematics. So you need to know the general form. When is it facing up, down? When is it facing up? And things like that. So all these points is what this video is about. So we'll take it from the beginning here, okay, all the way till we get to the coordinate geometry, and everything here is actually in a way connected. So this will be fun. Let's get on to it. Plane. This is also known as the Cartesian plane. Now we are going to look at just the one that is in 2 dimensions. And one thing that we've already explained is that this is also used to visualize or solve algebraic equations or inequalities. So now the Cartesian plane is, these are 2 lines which have got real numbers like that. Okay, they've got real numbers. And so you have these 2 lines or real lines that are perpendicular to each other. And so they meet at a point where it's 0, 0. Then you have the first quadrant, the second, the third, the fourth, like that. Why this is like this is like, normally we go like this when we look at this. Okay, so the first will be there, the second, the third, the fourth will be there. Doesn't really matter. It just depends on, these are just labels. So you just need to know that this is 90, 90, 90, 90 degrees, like that. So the first, second, third, and fourth. So here you have positive, positive, and positive. Here you have positive and negative. Here you have negative and negative. Here you have positive and negative planes, like that. Okay, so then the other important concept to understand here is that each point on this Cartesian plane is represented by coordinates, which are x, y. Okay, here it will be negative x, y, like that. Here it will be negative x, negative y. And then here it will be x, negative y. Generally, though, is to say that this is x, y, x, y, x, y, x, y. But I'm just showing you the signs. Let's say we have point P and point Q on this same Cartesian plane. So you have y-axis, and then you have the x-axis here. Okay, so now there are certain concepts that there are certain things that we can do on here that are important when it comes to maths. So for example, we can calculate the distance between these points. That's the application of this. So there are many applications. The first one that we're looking at is for calculating the distance between points. So if I've got these points here, I can connect them by a straight line. Okay, something like that. Right? Now, to calculate this distance, I have to consider two things. So there are two straight lines here. There's one line which is going like that. There's another line which is going like this. These form a right angle. And so if this was A, and this was B, and this was C, remember the Pythagoras theorem, okay? This is what we go back to. Theorem, okay? This is what we go back to. So what does it state? It states that the square of this and that equal to the square of this one here. So meaning that c squared is equal to a squared plus b squared, right? And so if we look closely at this, this is just from this point to that point here. So this is the x, but the x here we say is x2, and the x there is x what? x1. So we can say that distance from here to there is x1 minus x2, like that. Then from here, we can come back here and look at this, and then look at this as well here. So there, and then we look at this one here, it will give us this point here. But again, if we just check in terms of the y's, this will be y1, and that will be y2. So we can say this is b, and then a will be y1 minus y2. Okay, so now if we replace these into that equation, we'll find that c squared, which is the distance that we're looking for, okay, which is d. So c squared will be, we said that it's a squared plus b squared. So it's the same as this and b squared. Okay, we square this plus y1 minus y2, the square of that. C, which is d, distance. So we can already say that this is d. Okay, or we can say that this is p and q. So we can say distance between p and q is equal to. Now we can remember we talked about balance, that whatever you do on one side, you do on the other. So now we find this. Okay. So that is the distance. So normally x will have a number, y will have a number, y1 will have a number, y1 will have a number, x1 will have a real number. Then those are the ones that you replace in here to get the distance. So let's do one example. For example, if P, I'll just put it here. if P was 1, let's say if Q was 1, negative 2, like that, and this one is 8, 9, what would be the distance? So the distance here will be, we can say distance PQ is equal to, now we're replacing our equation. So we start with the x's. So the x is 8 here. We can say 8 minus 1, 8. And then the x2 is 1. So we do it like that. Okay. Plus, we get another one here. That's 9 minus 2, the square of that. So we get 7 plus, this is 9 plus 2, like that. So this will give us 49 plus 11 square. Still go for a square root there. This is 49 plus 121 square root. And then this will give us square root of 49 plus 121. That gives us 170, like that. Then you get the square root of this. That will be your distance. Another concept that we can use is to find the midpoint between these points. So again, it's good to think right angles when we are dealing with these Cartesian planes. So now we have this, and we want to find the midpoint of these, which will be x, y, right? So now what we do with this is we extract this line. Okay, we extract it like that. And then we have our points there. So we then put our point here, okay, which is the midpoint, and it's x, y. This is x1, y1, which we call P, and then this is x2, y2, which we called Q. And this is a point, some other point, M, midpoint, okay. So what do? We make right angles here. There's a right angle here. And then we can also have another right angle there. So now let's find what x will be here. Okay, so we're looking at the midpoint. So this is 1, this is half, 1/2, or this is half, and then that's half. Meaning that PM is equal to QM. Okay, PM is equal to QM. So the distance from here to there is the same. So we get the distance concept we did in the last video, and then we in the last concept, and then we use it here. So now how do we equate these two? We can just equate on one plane. So we'll equate on the x. So we can say x minus y1. So, or we can say x1 minus x, which will be this distance, should be equal to this distance here. Should be equal to this distance here, because we're looking at it in one plane. So this one will be x minus x2. So those two are equal. Now what do? We I'm thinking I bring this side, because that's where my x will be positive. So I take x2, I take it the other side. So I have x1 plus, this one changes to positive. We looked at various ways of doing this. Then this also goes there, becomes positive. Then that is x, like that, right? So now I'll flip this. This becomes 2x, because we are adding variables here. We check they are the same. The exponent or the powers are the same. So those can be added. So 2x equal to x1 plus x2. So now we divide here and we divide there. So x in that single plane becomes x1 plus x2 over 2. And y will also can be dealt with in the same way. And then it gives you y1 plus y2 over 2, meaning that the midpoint itself now will be x, y is equal to x1 plus x2 over 2. Then the y value, the y1 plus y2 over 2, like that. So that's what we get here. Now we know what this is. So this is our example. Always we just bring out the formula. So we say m x y is equal to it's going to be x1 plus x2. Then this one will be y1 plus y2, like that, over 2. Now here we collect our terms. This is 1 and 4. So 1 plus 4 over 2. Then this one will be 2 plus 4 over 2. So then we have 5 over 2. And then we have 3 this side. That will be our coordinates. So now another important concept is the gradient of the line. So the gradient of the line, you actually, it's called m, and so it's really just y over x, sort of. Okay, so you need to think of it in terms of this. So your displacement in the y-axis over the displacement in the x-axis, that will be your y-axis, your gradient. So the displacement in the y-axis here is y1 minus y2. The displacement in the x-axis, or the distance in the x-axis, would be x1 minus x2. So that will be the gradient of this line. Okay, so for example, if I've got 2 points P 1, 2, and then I've got Q, which is 2, 3, and then I take this as my first point and that as my second point, our gradient is going to be y1, which is 2, minus y2, which is 3, over the x, which is going to be 1 minus 2. So in this case, we'll have minus 1 over minus 1. So our gradient is going to be 1. So now we got the gradient, and so remember we said that this line has got the gradient called m. Okay, usually they represent it as m. So now the whole line has got a gradient that we are calling what? We're calling m, which is here. Okay. Now, this section here will have a gradient called m2. That section here, it will have a gradient called m2, m1. So we have m1, we have m2, and then we have m this side. Now, remember, this is still on our number line. So it could be something like that on our Cartesian plane. Okay, it could be something like this, where we have our x-axis, and then we have our positive y-axis this side. Okay, now, the next thing that we need to remember is that all these gradients are sitting on the same line. So if you get a section of this line here, it will have the same gradient as another section on this same straight line. On one condition, the condition has to be that the line is straight, okay? It doesn't matter if it's horizontal or vertical or at an angle, as long as it's a straight line. If I got this line here, okay, that will be my gradient. If I got my line, which is then it will get that particular section, the gradient will get the gradient of the whole line, as long as it's a straight line. Now, let's see what this means. It means that we're saying that M is equal to M1, right? Which is equal to M2. What is the implication of this? The implication of this is that we can get these two parts and isolate them, okay? So we get M1 is equal to M2, like that. Now, in our previous section, we saw that we could actually calculate the gradient by comparing these 2 points. And so we're going to compare these points and then we compare those points. But with one catch now, that these two are actually, they're actually equal. So what do? We start with X, we start with this one, okay? So we say the gradient was, remember the formula for the gradient was M is equal to Y2 minus Y1 over X2 minus X1. So the ones together, that's a secret, the twos together. If you mix up to say Y2 minus Y1 and then X1 minus X2, your gradient will have a wrong sign. Okay. So now here, what do? We say X, or we say Y, which is here. We start from here, going down. Y minus, the next point is Y1, okay, over X minus X1. We make sure we're doing the right thing. Then we go and do the second part, which is here. The second part there, right? So this second part will give us Y1 minus Y2 over X1 again minus X2. The subscripts are the same on each side. Make sure, because this will be like a X0, Y0 there. All right, so we take this guy and we take him across there. So we said whatever this is doing here, it does the opposite the other side. So if I was adding this, I go and subtract it there. But we know that obviously we multiply with the reciprocal here, but we know the shortcut. So we say Y1 like that is equal to, so this is dividing here, it will multiply the other side. Okay. This is Y1, Y2 over X1 minus X2. We maintain this and then we put this in brackets. Then this has come and visited us this side, so it will become like that. Okay, so that is our equation of a straight line that is going through 2 points. Normally they emphasize to say this is through 2 points. Our points are what? Our points are P and another point here is Q. Sorry, this is P here and another point is Q. This is not P. So P is here, Q is there. This is any other point. This is flexible. It can be anywhere. All right. So this is the equation of a straight line that is going through 2 points. Now let's do an example. So if this one here, okay, was now we're looking at it from the positive quadrant. Okay. So if this was 2,8, right, and this one here was negative, because it's in the negative section here. If that was, let's say, -2, -4, like that, what would be the equation of that line? And this is a special case here. Remember, we looked at gradient, because this is gradient here. Okay, so what happens here now? We look at these points. We're saying this is point 1 and this is point 2. So what happens? We are going to get y minus x1, y1, which is 8, okay, equal to, then we get our y1, which is 8, our y2 is -4, so we're going to say -4 here. And then what is our well, our x1, we say is 2. And then we're going to subtract our x1, which is what? Which is minus 2, like that. These we put in brackets. Always be in a habit of putting brackets because that helps you to segment your work. Okay, so now here we go to x minus x1. x1 is what? Minus 2. x1, sorry, it's 2. It's 2. Like that. Okay, so let's continue. So this is going to give us y minus 8 equal to, okay, equal to, we continue here, there will be positive there. So we know that it's 8 plus 4, which is 12. This gives us a 12. This we know is going to be 2 plus 4, 2 plus 2, which is 4. So we divide by 4. And this is going to maintain what it has, like that. We continue. This becomes y minus 8 equal to 3x minus 2. Continue it there. This becomes y minus 8. And then this becomes 3x minus 6. Very careful. We need to be very careful with our signs. So that becomes now y equal. Now this moves the other side and becomes a positive. So that's positive 8 minus 6. So that gives us 3x plus, okay, 2. And that will be our equation of this line. Okay, now there are special things here. This is going to be where it crosses the y-axis, and then this is going to be where this is going to be the gradient. Okay, why are we saying that this is where it crosses the y-axis? Because when x is 0, it's going to be there. So when x is 0, its y is going to be 2. So this is going to be 2. There's a special formula that we can derive now based on this case. So that will be our next section. Thank you. So another variation of this equation then is to understand the application of gradient. So when the line is moving in that direction, we say that it has a gradient which is positive. Okay, so the gradient for this line is going to be positive. Once the line is moving like that, then we say that the gradient is negative. Okay, you can actually work it out and it will be negative. And then once the line is like this, it's following the x-axis. Okay, we say that the gradient is 0. Okay, so this is what we call the 0 gradient. And then when the line is vertical, following the y-axis, then that we say that the gradient doesn't exist. Okay, it's non-existent. So the gradient here, there's no gradient. Okay, now why am I talking about this? I'm talking about this because it's very important to understand that for any line that has a gradient, the line at some point is going to have an intercept if you continue to draw it. Even if it was a small line like this, just like that, I can actually extend this and get what it means here. Okay, then I should be able to work out the equation of this. So another variation of the equation of a straight line is the equation that uses the intercept. So now let's work it out and see what the general equation of a line going through an intercept is going to be. So now if we consider the intercept will be where we are saying that x is 0, and then the intercept, they give it letter c normally. Now you have xy like we discussed before. Now there are two concepts that we're going to put together. This concept here, and then another concept we said was we worked out what gradient was, and we said it was m. Okay, so we said when you have a situation like this, you have your gradient, right? So here we're going to have y minus y1 is equal to, now we're going to have m here. We're going to replace this whole expression with xm. So this becomes mx minus x1, like that. Okay, so that becomes the next step of our equation. Okay, now that's the first part. Remember, this is the first part. So this is an equation that's actually usable. You can actually calculate the gradient, put it here, and then get the point that you're given. So this is also an equation that we can say, maybe let's say this is equation number 2. The first is this one. Okay, so that's an equation that you can apply, and this is an equation that you can also apply. Now we go to the third type of equation. So now we're going to get this point and replace it into this equation. So what is our y? Our y1 is going to be c is equal to mx, like that, minus x1 is 0, like that. So what is our equation if we continue? It's going to be y minus c is equal to mx, because this became a 0. Okay, now we can take this guy and throw him the other side. So this comes this side. That is how I like to do it. It's a shortcut. You can add c here and add c. It's another way. Okay, all right. So this is our equation. Okay, so this is another equation. So this is the third type. So you can actually use this to get the equation. You can use that to get an equation, or you can use this to get an equation. Okay, so if they asked maybe a question to say find the equation of the straight line, maybe they'll give you this point here and another point. Okay, so what we have to do in that case is to calculate the gradient. Okay, and then we calculate we collect the c, we put it there. That will be our equation of the straight line. Let's do an example. Okay, so we're trying to get the equation of this setup here, the equation of this line here. Okay, so now what are we seeing here? We said that what I'm expecting is, once I'm done, one of the checkpoints I'll have is to make sure that my gradient is negative. So what's the first thing we do is we calculate the gradient. So how are we going to calculate the gradient? We said it's m is equal to y1 minus y2 over x1 minus x2. Now, here, we need to make sure that the subscripts are sitting on the same side, 1, 1, 2, 2, like that. You don't do y2, y1, then it will give you a wrong sign, so the gradient will be wrong. And when the gradient is wrong, it means that this is in a different alignment. So now we start with y1. I'll take my first point as this one. So I'll do y here is going to be 4, right? So I'll do 4 minus 0, okay? Then I'll go down here and do my, I'll do my x is 0, and then I'll subtract my 6. So by look of things, we get a negative gradient here. Okay, so our negative gradient is reduced to that. Now we can also continue here and look at what the intercept is. What's the intercept? We said the intercept is going to be this point here. So what's the value of y at this? It's going to be 4. So we get 4. So our equation therefore is going to be y is equal to minus, this is our gradient, 2 over 3, x plus our c, which is 4, right? I can change this a little bit by multiplying throughout by 3 to remove the 3 here, to remove the fraction. So if I multiply this whole equation by 3, okay, I'll get 3y equal to negative 2x plus 12. Okay, I can also move this to the other side to remove the negative. Then my whole equation therefore becomes 2x plus 3y equal to 12. It's the same. Okay, so that's our equation when we use the intercept to work it out. But what you can also do is maybe try to get this same equation using the first formula that we worked out. It also should be able to work without really having to calculate the gradient. You just put these 2 points in and then it gives you the equation. Thank you. We move on to the geometry of a circle. Now, here, the important thing to note is that we still have these lines. We're still working with lines. There's nothing different. It's just that now you're working with hundreds of lines or millions of lines that have same distance from one point, like that. So that's what these are all about. Now, if you look at all these points, the same distance from the center. Okay, the same distance from the center. That's the only thing that changes. But these remain to be the lines. When it's half the distance, we say it's radius. When it's twice when we put this together, we say it's going to be the diameter. Okay, so it's the same thing. So now we still get the same concept of distance that we looked at, which is this and that. So this is our formula, meaning that the center of the circle is normally represented as HK in most books. Then these points, any other point on the circle, will be XY. Those are the coordinates. So meaning that in our example here, the distance between P and C is our radius. So we can say R squared, or R in this case, because we've already included the radical sign. So R is equal to, we can now say square root of, now we use our first point, which is X, then we subtract H, okay? And then remember this is squared. Then again, we go to Y, Y1 in our case is Y, minus, we subtract K, which is our Y value here in the center, okay? So that is going to be the radius. So if you get any point on the circumference here of the circle, and we on the perimeter of the circle here, and we use the center, then we're going to get the equation for radius, like that. So this is equation number 1. This equation can be expanded into R squared is equal to X minus H squared plus Y minus K squared. So this is the general form of the equation. So now an example would be if we were to calculate the equation of a circle which has radius, let's say 3, and diameter and center 2, 5, like that. What would be the equation? So here we can say 3 squared is equal to, we place our values there. So X, H we said is 2, plus Y minus 5. So we have 9 is equal to X squared, X minus 2. We don't forget our square signs. Then plus, here we get Y plus 5 squared. So let's look at this tricky question. So they're asking us now to do a number of things here. They're saying check if this equation is for a circle, and then extract the radius and the center. Okay, so this is our equation here, right? This is our equation. Now, what is our solution plan? What is your solution plan? So the solution plan here is going to be that one, we need to set it up into the general form. Okay, this equation, we change it, the format, into the general form. Then once we're in the general form, we can extract the center, and then we can extract the radius from the general form. And then we have to look at our strategy. How do we get to these? We get to those using our completing the square method. That's why in the beginning there was emphasis that all these concepts that we're doing from the very first video to now, they have to be followed step by step, and then you have to be able to apply them as you go. Okay, otherwise it's very difficult to become really exceptional at something once the fundamentals are not very good. So now let's look at this, and let's look at this. So now the first step is we collect our like terms. Okay, just like that. That's the first step, just like this. And then our 7 is alone there. Okay, this was equal to 0. It's an equation. Okay, so now what's the next thing? The next thing is that we complete the square here. So I'll put this in my square brackets like we did in the beginning. Then plus 2x. I'm already recognizing that to create this into a square of factors, I need to add 1, because I need to recognize that equation. Then this I'll do like that. Then I'll take away 1 because we need to maintain the balance. And then I'll make use of my square brackets again. Okay, and this. Then I'll do minus 6y. Here I'll know that I divide by 2. And then I have plus 9. Okay, but I still need to take the 9 away so that I still maintain my balance. And then I'll still use my square brackets, and then I'll add my 7 equal to 0. Now we will recognize that this one gave us the product. Now the product here is 1, so, and the factors are going to be 1 and 1, that will give us 2. So already we know that this will give us this square. There's a video we did on completing the square. If you don't know how to do this, that will be minus 1. I still maintain my square bracket, but this time I open this up. I go to this one. I know that this is 9. So it's 3 and 3. They'll give me this, but minus 3. Okay, so I have to be very careful. So I have to do minus 3 here. Okay, this will be squared, right? Then I have my 9 outside here. Then because I've opened it up, I can now close here. Then plus 7 is equal to 0. Now remember, we said that this is x plus 1 squared. This and this can come together. We get our 10. Okay, that will be 10 minus 10. Then now we can open it up. There's nothing that is there's no negative that's impacting anything, so we are safe. Then we can do that. This is going to be x plus 1 squared, very carefully. Okay, y minus 3, like that, squared. Then this is going to be minus 3 equal to 0. Notice I'm just changing one thing, then I'm writing the equation again. This is how you must learn to do this. Then I take this to the other side. We say that you can either add a 3 and a 3 there, then that will still give you this. Okay. So we have our 3 there, right? Now, remember now that our equation, the general format of our equation is x minus h, like that, squared plus y minus k squared equal to r squared. Okay, so now we can get this and equate to that. So we can say, you can even say x minus h is equal to, like this. So I can say now, to avoid mistakes, so I can say x plus 1 is equal to x minus h, like that. So these cancel out, and then I'll get my h is equal to minus 1, right? Then I do the same. I can do y minus k is equal to y minus 3. These two cancel out, and then the negatives take care of themselves. Then we'll have k is equal to 3, right? Then the other one that we can, sorry, I'm doing it this side, is r squared is equal to 3. We said we apply the same concept on both sides. So we have r is equal to root 3. That's the radius. So the radius, we have it here. Okay. And then the center, we can say that now we get these. We say the center is hk, like that. So we get them just in their original formats here. So h is minus 1, and then k is 3. Okay, because now we don't have to change anything. Okay, so that gives us the center and also the radius. So you have the radius, you have the center, and we could see that this was actually in this format. Okay, and that's why, so we can confirm the 3 things. Is this a circle? Yes. What is the center? Minus 3, comma 3, minus 1, comma 3. And then what is the radius? It's the square root of 3. So now we continue and look at the graphing of the quadratic equation, still on coordinate geometry. Now, these are shapes of quadratic equations. So you will get them in these 2 formats. Now, you will see that this graph grows this way, and that graph grows that way. That's the primary thing that we need to know. Okay? It doesn't go anywhere beyond here. It doesn't go anywhere beyond there. Meaning that this graph, okay? Meaning that this graph can only grow this side. That graph can only grow that side. This is the first visual that we need to have, right? Then the second thing that we need to know about quadratic equations is that we are going to maintain the same form of the equation, which is ax squared plus bx plus c equal to 0, like that, right? What is crucial now to know, the next thing is we need to know a number of things. The first is the solutions, okay? The solution set. So this is where it intercepts the x-axis here and there. What is the value here? This is when y is equal to 0. Number 1 concept. Number 2 concept, we need to understand this point here, the vertex. So they call this one the vertex. We need to know this, okay? The number 4 point is that we need to understand this point here. When x is equal to 0. When you have these four aspects, let me write them down here because these are so crucial. I'll write them in green. Number one, you need to know the general direction. Okay. Direction of the graph. Number two, the solution set. Number three, the vertex. Number four, it's the y-intercept. If you know these, then you can graph a quadratic equation onto the graph. So now, what is important here? What is important is to know the general direction, the solution set, the vertex, the y-intercept. That's what you need to carry with you as we go through these series of equations. Okay, now let's say you have you've been asked to plot a graph of an equation like this. So we said that you need to know the general direction. Okay, so the general direction, assuming this is positive, so I'll just do this, okay? Then I'll get my solutions. So if I get my x is here, maybe x1, x2 will be there. I calculate the values of the intercept, the vertex. Then I calculate the value of the intercept, like that. Then all I do now is that since I know the general direction, I can come and do this. Now, you usually miss just a bit. These don't have to be accurate when we are doing them at this level. We just need to have a general direction of that. So you had the value of here, you had the value of there, the value of here, and this value. This value, that's why it's not very common to include it when you're drawing, but you just need to know this one, that one, and that one, and then this one finds itself as you're drawing it. Okay, so you don't need to have accurate values like everywhere it's going through where you want it, but it should be in that general direction. So if you understand that this is positive, when it's positive, then you know your graph will open this way. The main reason why it opens that way is that the values of x squared keep on increasing. So whether it's negative, it's positive, they'll keep on increasing. The values of x, they'll keep on going that way. The reason why it goes downward like this, when you have a negative value here, it's because this will always be negative, meaning that as you are going towards infinity, this side and that side, this value will overpower these two values. Regardless of whether they're subtracting or adding, this will overpower the rest of the values. And so the general direction will follow this value here. Okay, so for example, if x is at infinity, for example, we'll have the square of infinity is here, but here you have a single infinity, there you have none. So the biggest value will come from here. So if this is negative, the general direction of the graph will be negative. If this is positive, the general direction of the graph will be positive. Let's do the actual points. So this is y is equal to ax squared plus bx plus c. Right. So what we need to understand is that the solutions, okay, the solutions for this equation, y, okay, is going to be this value. But x, the values for x, we'll get them through you can do the factorization method, or you can do the completing the square, or you can do this one. Doesn't matter as long as you're doing it correctly. So this is, you get your x values. So this is 1. The general direction, we'll get it by checking the sign of this one. Okay, so the sign of that one, we'll have an idea whether this is opening upward or it's opening downward. Now, we've got the values of x, and remember there are 2 based on this, because 1, you take the positive route here, 2nd, you take the negative route. Then the other value we said was important was the vertex. The vertex comes from the completing the square method. And so the value they say is like this. Why? When you complete this, it becomes a, like that, x minus h squared plus k. Okay, when you change the format of this equation to that format here, okay, through completing the square, the value that you get here and the value that you get there of h and k gives you the vertex. So the vertex is h comma k. Okay, so it's easy. We've already used this formula and how to get it, and we know how to solve, or to solve quadratic equations. The solutions that we get, they give us the points on the x-axis, okay, because there y is 0. And now let's try to learn how to come up with the vertex, because we already know how to do the solutions. So this next section, we'll try and know how to come up with the vertex. Let's get the vertex. So our formula is ax plus bx plus c. So we're going to go with completing the square method. We say that first, x has to have, for us to use it, x has to have a coefficient of 1. So that's why we factorized a, but then that will impact this one as well. A, okay, x, then plus c over a, like that. Then we look at this and we complete the square there. Y is equal to a. If we completed the square of this, we're going to end up with x plus b over 2a, that we're going to square. Then the same time, we're going to take away the square of this, okay, which is b squared over 4a squared, then plus c over a, right? Now, we need to remember that we are trying to have it in this format. Okay, so already we now need to expand this. Okay, we need to, first of all, before we expand, we need to set it up that it can be in the same format. So that becomes over 2a squared. Then here we say plus. If I say plus here, then this minus, we need to go inside the brackets there. Okay, so it will be minus b squared over 4a squared plus c over a. Right, I can factorize this. Okay, so it's going to be a squared, a, like that, then x plus b over 2a squared again, and plus. Here, I go into my brackets, and I'll have, so let me simplify this. Here, I'm going to have, let me set up the negative that is for all the values, so it's minus here. Then this one on top here has become positive, because now I'm saying the whole statement is negative. Okay, not just b squared. So that changes this one into negative 4ac. Notice I'm saying the whole sign there. So this has become positive. And then at the bottom, we're going to have 4a squared. Check out the video on the negatives and positives. That will help you to understand what has happened here. it's the same. Remember, if we say minus b squared minus 4ac over 4a squared, this is not the same as minus b squared minus 4ac over 4a squared. These are different. This is the same as this, like that. And this is the same as that. Notice where the negative now is. Different places. I can't expand this negative to anywhere else. I'll have to keep it there. But here, I can expand this to minus b squared. Then it will change this into a positive. So when it's in line with this over sign, then you know that it's applying to the whole statement. When it's just next to this letter here, okay, it's applying just to this letter, not to the whole equation. That's why I put it there. And then I changed the nature of my equation there, okay, to mean that b squared now is positive, but 4ac is negative. Or if you want, you can put this in brackets further like that. Okay, so now we continue. We expand with the a. The a stays with x plus b over 2a, like that. We square. And then here we maintain our plus. Now, remember, I'm going to simplify it. I'm going to keep it like this so that it's easier for us to pick it out. Minus. And then what we'll do is we'll maintain this b squared minus 4ac, like that. But this a can come in and cancel part of this. So this becomes 4a. Like that. So now we see that these are in the same format, which is y. This is y. Then I can put y is equal to a, which is the a there. Then x minus h squared. This is the same. Plus k. So we have the plus, and then we have the k. Meaning what? Meaning that we can now say that x or h is equal to minus. Remember, this is minus and that is positive. So at the end of the day, if I want to say h, I'll have to transfer the negative to this guy here. So it will be over 2a. Okay, that's the vertex. So this is x at the vertex. Okay, x at the vertex. What is k? What is the coordinate of k? What is y at the vertex? It's going to be this. So what is this? What is this? This is k. So we're saying that k was positive. This is negative. So we maintain what it was. So this is minus b squared minus 4ac over 4a, like that. So these are your coordinates at the vertex. So the vertex, we conclude it like this. hk at the vertex is going to be minus b over 2a, comma, minus b squared minus 4ac over 4a, like this. So this is another of the formulas that we need to master. Okay. They've given us this equation and they're asking us to sketch the graph of this quadratic equation. Now we said that there are 4 steps. The first is to find the general direction of this graph. So this is a positive number, so we expect it to open this way. We explained why this is so. It's because of this. This is more powerful than these two because it's got 2 x values here. So for example, as we are approaching infinity, these will be very huge numbers, 2 very huge numbers multiplying each other. But this one will be a 6 and that huge number. Then this one will remain as a 5, meaning that even if we were to add these 2, it's impossible to compare with the value that we get from here. And that's why it's opening upward. Whether it's negative or positive value of x, there will be, remember, even if it was negative infinity, we square it, that becomes positive infinity. So still it will go up, whether the value of x is negative or positive. So we know that the graph is opening upward. 2, we look for solutions of this graph when y is 0. Okay, we say that this, the product is 1, then to get minuses here, it means that we've used factors of 1 and 5, okay, equal to 0, meaning that those two solutions, we're going to have x is equal to 1 and 5. Okay, so those are two solutions. We've ticked the first point, the second point. Then we have the third aspect, it's to find the vertex. We said that at the vertex, x is equal to minus b over 2a. Okay, so what is minus b? Minus b is going to be minus 6 over 2a. 2 is, a is 1. You can see that a is 1 here. So meaning that we're going to have 2 times 1, which is 2. The top part gives us positive 6. The bottom part gives us 2. Those two divided, we have 3. What is the y value? Y value, you can put it in this equation here, the value, the 3, and find it. Or if you are able to remember, we said it was b squared minus 4ac over 4a. So we can go minus. The minus is not in front of b, it's in, for the whole expression. So then we do b squared, which is 36, minus 4, a is 1, and then c is 5. Then we divide by 4 times a, which is 1. So now we have what? Minus. Here we have 36. Here we have 20, so that's 16. We say 16 over 4, and so we get minus 4. Okay, so this is the second part. We have the vertex. So our vertex is going to be 3, 4, 3, -4. And then what's the next thing that we can work out? It's we're going to work out where x is 0. So y is going to be x squared is 0, minus 0, 6 times x, then plus 5. So y is equal to 5. So at the point where x is 0, the graph crosses the y-axis at coordinate 0, 5. So we have our general direction, we have our vertex, we have our solutions, and then we have this. So now we can graph our thing. So it's going to be, okay. I don't want to use lines, I want to draw so that we can actually have a feel of what's going on. We can get lines, put them down, and go. We don't want to do that. So now we use the solutions. So these solutions are 1. Okay, those are the first ones you must put, and then we put a 5 there. So this is going to be 1, and that's going to be a 5. What other point can we look for? It's this 3. So we're going to say this is minus 4, because this is the y-axis and this is the x-axis. And then here we're going to say 1, 2, 3, 4, 5. So it's going to be somewhere in the middle here. So this point is going to give us the vertex. So we show it there. Which other point can we include? We can include a point here. Okay, here where y is 5. So meaning that now our graph will be something like this. We connect here, we bring it down, it connects here, we bring it down, connects here, we bring it up, connects there, and here it just continues like symmetry, like that. Okay, so this is how you draw the graphs of quadratic equations. All right, thank you. Okay, so this concludes our section on fundamentals of precalculus. Thank you for following, and all the best.